Hello everyone. So now we are going to solve problem of the day for 15th October. Let's read the problem. There are n balls on a table. Each ball has a color black or white. Fine. Given a zero index binary string of length n, where one represents black and white balls respectively. So one means black, zero means white, five, zero means white. In each step, you can choose two adjacent balls and swap them. Two adjacent balls and swap them. Suppose this is the position of balls A, B, and C. The possible swaps are you can either swap A and B, you can either swap B and C, but you can never swap A and C because they are not adjacent. Adjacent means side by side. So B is adjacent to A, but C is not adjacent to A. Similarly, A is adjacent to B, but A is not adjacent to C. But B is adjacent to both A and C. Fine. Now let's move on to the problem and swap them. Okay, return the minimum number of steps to group all black balls to the right and all white balls to the left. Okay, so we can either proceed with any of them because if all black balls are to the right, that means all white balls are to the left. Okay, so let me take the first example 101. 101. So what can we do? So our objective is to move all the ones to the right. So what we'll do is basically we'll swap this one and this zero, which will result in the string becoming 0, 1, 1. That means we have received our answer. So it took only one step. Fine. What is the next example? 1, 0, 0. Now, ideally, the best answer would be to swap this one and this 0. That would give us the answer in one step. However, as I mentioned earlier, we can only choose two adjacent balls and swap them. So what this one and this 0 cannot be swapped. Rather, what we have to do is swap these two, which will result in 0, 1, 0. And then what we are going to do is swap these two, resulting in 0, 0, 1. So the answer is 2. Clear? Next example, 0, 1. Okay, all ones are to the right, so this does not need any. Okay, fine. So let me take a few examples. Suppose this is my string 0, double 1, double 0. So what we will be doing is suppose I am taking the rightmost one, that is this one. Then what I can do is I cannot directly swap it with this 0. Fine. However, one thing I can do is I can swap this one with this 0, which will result into the string becoming 0, 1, 0, 1, 0, and this will, and again swapping these two will give me 0, 1, 0, 0, 1. So one thing I can directly see is If I want to directly swap this one and this zero, I can do it using two steps, right? Okay, fine. So what if the string was only this? I'm taking an example. Mm, I think, okay, so let me move this to the side. Suppose this one's 0, 1, 0, 0. Let us take a case that at this point, which is the first index since indexing starts from 0 for a string. So at the first index, the number of black balls, that is the balls which are represented by 1, is 1, right? Is 1 at this point. So what do I do? In the next step, if I want to swap it to this point, it will result in one more swap. So what can I do is if I find a1, I will increase the number of black balls by 1, and if I find a 0, I will be adding up the number of black balls before that point to the current index. Okay, let me explain it that in a better way. Suppose 0, 1, 0, 0, 1. Suppose this is my string. So initially I will be 1, count of black balls CNT. Okay, initially I will be 0, sorry, my bad. Count of black balls will be 0. This is before we are even starting something. And answer will also be 0. So first index I got 0. So what will we do if I get 0? 0 means I will be adding the number of white balls, number of black balls before that point to the answer. So the number of black balls before that point is already 0. So I add 0 to 0, which remains the same. In the next iteration, I find a black ball. So the number of count of black balls will increase to 1. Fine. Now I move to this index. I get 2. Okay, now note that since this is 0, what will I do? To answer, I will add the number of white balls before that, which is CNT. So it becomes 1. Then I move to this. Again another 0. So I add the number of white balls before this to answer. That makes it 2. Then I move here. Count becomes 2. And I need not do anything. Okay. So let's do this thing. What would be the actual answer? Suppose 0, 1, 0, 0, 1. I will be swapping these two, which gives me 0, 0, 1, 0, 1. Then again, I would be swapping these two, which gives me 0, 0, 0, 1, 1. So I arrive at the answer. Let's take another example. Okay, fine. Let me do this one as a text. It will be easier. 1 0 1 0 0. So this means this is the worst thing. So let me see if I have to count it without swapping to ensure that this one reaches from here to here. How many swaps will it have to endure? One, two, three, right? And what about this one? What about this one? Now, since the one to the right has already reached the last, what we are going to do is I will swap it here. So this again endures one, two, three swaps. So the answer will be 6. Now, again, let us try with that previous analogy 1 1 0 0. So I will be 0 initially, count will be 0, and so will be 0. So when I is 0, the count of black balls increases to 1 is here, right? Then I move to the next. The count of black balls increases to 2. Now note, in the next case, since this is 0, what were we doing earlier? We will be adding the cumulative count of the number of white balls before this. So this becomes 2. Now what it actually does is, let me show you here. What it actually does. Let's take this here. So when I am doing this, that is adding the cumulative count to the answer, this process takes place 1 1 0 0 0. These two ones together get swapped with this 0. So this becomes 0 double 1 double 0. Now for this to take place, I'll have to endure through two swaps, this one and this 0. Then the 0 comes, when the 0 comes here, then again this one and this 0, making it 0 1 1 0. So I could endure two swaps to reach this point. That is, all the cumulative ones before that 0 got swapped with that 0. So the number of swaps will be equal to the number of cumulative ones before that. Fine. So that's the thing. Now let me try to code it here. Let me take the size of the string. Fine. Now you can see that the return type is long, so I will take long and equals to 0, comma black count equals to 0. Now let me create it as the whole string. So if s of I equals, what was I doing? If si was 1, I would increase count by 1. If si equals 1, I'll increase count by 1. Else, I will be adding c2 and plus equals to plk underscore cnt return ans. Run it. So let me add another test case here. Triple one. Okay. 1 1 0. Now what would be the answer here? Let me continue. So it now, so one was at 2. Now one will reach 3. 3 is again 3 again another 0. So I add 2 to this. Then this becomes 4. 4 is another 0. So I add another 2 to this. I get the answer 6. And let us test if we are getting the answer 6 for this test case. Yes, we are getting 6. So let me submit this. Yes. So that's the right answer. I guess you understood the question. Thank you for watching.